Hi, my name is Shastine Partap, and this is my oral component of my proposal on graphene for my Technical Communications course. What is graphene? Graphene is a monoatomic thick carbon allotrope. It is 200 times stronger than steel. It is the thinnest material on Earth, 1 million times thinner than a human hair, and the most conductive material known to man. So who discovered graphene? First we have Andre Geim. Sir Andre Constantin Geim, born October 21, 1958, is a Russian-born Dutch-British physicist at the University of Manchester. Geim was awarded the 2010 Nobel Prize in Physics jointly with Konstantin Novoselov for his work on graphene. He is Regius Professor of Physics and Royal Society Research Professor at the Manchester Centre for Mesoscience and Nanotechnology. His field is in condensed matter physics. He is known for the discovery of graphene, levitating a frog, and developing gecko tape. Next we have Konstantin Novoselov. Sir Konstantin Sergeyevich Kosta Novoselov is a Russo-British physicist, known for his works on graphene together with Andre Geim, which earned him the Nobel Prize in Physics in 2010. Novoselov is currently the Professor of Physics in the Mesoscopic Physics Research Group at the University of Manchester and a Royal Society University researcher. His field is in solid-state physics. He is known for his study in graphene. How was graphene discovered? Graphite is a mineral form of carbon. The lead in pencils is graphite. Geim and Novoselov had to shave off very thin flakes of graphite. They had no luck until a lab technician showed them how to strip off layers of graphite with the aid of transparent tape. The scientists redefined their technique and they were able to peel off a layer of graphite just 1 atom thick, and graphene was born. It was originally referred to as the Scotch tape method, but it is more formally known as the micromechanical cleavage
Two
tape.
Russian-born scientists shared this year's Nobel Prize in Physics for experiments with a substance they discovered in 2004 called graphene, the thinnest and strongest material on Earth. A layer of graphene is a single atom thick, so tiny it would take more than 1 million sheets stacked on top of each other to reach a single millimeter tall. But if you stretched a sheet of the carbon-based chicken wire-shaped material over a coffee cup, it would be strong enough to support the weight of a car. Scientists think that in the future, the wonder material could be used for high-capacity batteries, flat-screen TVs, and for ultra-small computer chips, its most promising use. And despite its amazing properties, graphene isn't rare. In fact, anytime you write with a graphite pencil, graphene is produced. That's how it was first isolated by prize winners Andre Geim and Konstantin Novoselov, who used Scotch tape to collect graphene from pencil lead. Which just goes to show you don't need a lot of money to win a Nobel, and almost none to win an Ig Nobel, the yearly prize for the least distinguished scientific research. Past winners of the Ig Nobel included a Welsh scientist who invented a high-pitched noisemaker designed to scare away teenagers, a researcher in Australia who studied belly button lint, and one in sociology for a PhD student who wrote his thesis on Canadian donut shops. In 2000, one of the Ig Nobels went to a scientist who levitated a frog with a magnet, whose name was Andre Geim, who 10 years later became the first individual to win both an Ig Nobel and a real Nobel when he shared this year's Nobel Prize in Physics for pioneering research on graphene, the world's strongest material.
What is graphene's molecular setup? Graphene's atoms are arranged in a single hexagonal sheet which allows for excellent conductivity. Because of this unique structure, graphene is known as a conductor, which means it provides a steady and current flow of electricity. Scientists are experimenting with the stacking of sheets of graphene on top of one another to allow electrons to flow between the layers. The molecular shape of graphene resembles chicken wire or honeycombs. What is graphene being used for? The University of Central Florida's chemistry and engineering facilities have been conducting experiments with graphene and making groundbreaking discoveries, including methods of mass production. Both Richard Blair, a chemist in UCF's Nanoscience Technology Center, and PhD graduate student David Respo used a combination of chemical and mechanical processes to break down graphite and transform it into graphene. The Nanoscience Technology Center at UCF is also developing a new program to make a graphene-based spray coating that would help multiple industries easily and inexpensively fight corrosion. Willie Paul and Chandra P. Sharma from the Division of Biosurface Technology and the Biomedical Technology Wing at the Sri Chitra Tirunal Institute of Medical Science and Technology in India believe that graphene could be an excellent material to assist in the biomedical field regarding drug delivery and biosensor application. The recent discovery that graphene is compatible with blood and can be safely used in various human body applications has been a staggering advancement in the use of graphene in the biomedical sciences. Does graphene have any siblings? Similarly to graphene, boron nitride also has its atoms arranged in a single hexagonal sheet, with boron and nitrogen alternating in the empty spaces where carbon atom sits in graphene. Electrons pass through the stacked boron nitride and graphene, thus causing electrons to zip through with ease. Silicon nitride is a known sibling to graphene as well. Silicon is also known as carbon's big brother. Because carbon sits right above silicon on the periodic table, it is possible that silicon could form flat sheets comparable to graphene. Scientists have discovered that thin layers of silicon have the similar honeycombs of hexagons found in the structure of graphene. Is graphene dangerous? Yes. One form of graphene has been suspected of toxicity, graphene oxide. However, there are potential methods to reduce toxicity of graphene oxide and make it user-friendly. Graphene oxide induces cytotoxicity, which is self-destruction caused by cytotoxic substance, and genocytotoxicity, which are damaging to DNA and can result in cancer. But group density on the surface of graphene oxide sheets is the main cause for cellular toxicity. Particle size, particular state, and oxygen content of graphene are key issues in its toxicity to human red blood and skin fibroblasts. When graphene oxide made contact with surface water, which is drinking water, it floated around. This suggested that graphene oxide could be ingested and could create toxicity in the body. Is graphene dangerous? No. It has been experimentally proven that graphene is compatible with blood and can be safely used for various human body applications. Graphene oxide may be toxic in certain scenarios, but it can be controlled by safe methods of disposal and working in controlled environments. There are potential methods to reduce cytotoxicity of graphene oxide and make it user-friendly. Graphene oxide's toxicity does not rule out the usage or further experimentation. This just ensures that proper precautions will be taken regarding safe methods of disposal and working with graphene oxide in a controlled environment. Welcome to the graphene age. This next section will explore the future developments due to graphene, such as bendable and lighter smartphones and laptops, lighter and more energy-efficient aircrafts, trains, and cars, batteries that take only minutes to charge from exposure to sunlight, last longer, and are lighter, super-fast broadband internet, downloading 3D films in a matter of seconds, new water filtration technologies to turn seawater into drinkable water, and even new medical technologies ranging from artificial retinas to tissue regeneration. The possibilities are endless with graphene. Flexible screens. Researchers in South Korea have produced a continuous layer of graphene 63 centimeters wide. This has opened up possibilities in electronics that no one thought possible. Scientists are saying that one could theoretically roll up an iPhone and stick it behind the ear like a pencil. Mobile phones. Nokia is exploring the potential uses of graphene in mobile devices. Aside from smaller, more flexible phones, it may allow built-in solar power and transparent electronics. Solar panels. MIT professors have shown how graphene could be used to make the electrodes in organic solar cells cheaper, lighter, and more flexible than those in current systems. DNA sequencing. Researchers at British firm Oxford Nanopore, building on discoveries made at Harvard, claim that using graphene could reduce the cost and speed of the process of DNA sequencing. Through this proposal, I hope to convince the Burnett School of Biomedical Sciences, branch of the College of Medicine at the University of Central Florida, to administer the use and further research of graphene-based materials. Graphene is inexpensive, easily manufactured, and more efficient when compared to silicon nitride. One form of graphene, graphene oxide, may be toxic but can be sufficiently controlled to utilize the many advantages and numerous improvements graphene can offer.